couple of weeks ago, we let a wheel and axle roll down a ramp, which started our exploration into uniform acceleration. Most students did this during class and also did the experiment through Pivot, or maybe had both their trials through Pivot, where the wheel and axle was speeding up in a positive direction. As people collected data from either of these experiences, they built time and position data tables, and from that, they built position versus time graphs. And so you previously had come up with position versus time graphs that looked like this and had a top open curve. On this one, I've got position versus time graphs from a less steep slope and then a steeper slope. And you can see with the steeper slope from trial 2, the wheel and axle sped up more quickly. As we continued our exploration through uniform acceleration, we learned about an average velocity through a time interval equals the instantaneous velocity at the time midpoint, and also realized we could find acceleration by looking at the slope of a position versus time square graph, in which case that would be half the acceleration. So we're going to spend a little time today taking our real wheel and axle data, the ones you took from in class or from Pivot, and you're going to build your own table like this. So again, using your real wheel and axle data that you used in class, I'm going to use some fake wheel and axle data, and this is actually similar to the ones that we've been using on the worksheet. The first thing you want to do is copy your time and position columns, and then you're going to want to open up a new sheet. So just add a sheet, and we're just going to paste that information in there. So you got your clock readings and your positions. The first thing we're going to do is we're going to create a time squared column. To make a time squared column, it's considered appropriate for t squared to do a t, the caret, which is a shift 6, and that's the second power. I'm realizing now that I didn't have seconds squared for my units, and I need to include that as well. So there's two ways you could do this. You could take these clock readings and multiply themselves and just put the values in here. But using a spreadsheet, the power in this is being able to tell the computer what to do. So if you put equals in here and you click the box that has your clock reading in it, and we simply want to multiply that, so I'm going to hit Shift 8 for the star and click that same box again, we'll hit Enter. Now, once we've done that, it's going to prompt us, would you like to autofill? In other words, do they want to use that formula through the rest of this column, which will square all of these clock readings for you? Let's hit go ahead. And you can see that 1 second squared is 2, 2 seconds squared is 4, 3 seconds squared is 9 seconds squared. So that's taking care of that. But to create the full data table, we would want to be able to do change in time, change in position, time midpoint, and average velocity like we had last week with worksheet D. So how do we go about doing that? Well, the first thing we have to do is, remember, we had to shade in the areas in there because we wanted to talk about the intervals. So the first thing we need to do is we're going to insert a row between our first and second clock reading. So we'll go in here and hit Insert a row above. Now, a lot of you know that Command Z will revert back to the most recent thing, but there's also a Command Y, which will redo the most recent thing you've done. So I'm going to come down here below on my second clock reading, and I'm going to hit Command Y, and it'll do the last thing, which is basically putting that extra row in there. And I come down to 3 and I hit Command Y, and it puts those extra rows in there. So row 3 at this point would be for in between my clock readings of 0 and 1, and 5 would be in between clock readings 1 and 2, and so forth. Well, how do we calculate a change in time? Well, to do that, again, you have to hit the equal sign, and literally we want to change the time. So you take the second clock reading, and we want to subtract the first clock reading and hit Enter. Now, once we've done that, we can grab this box here and drag it down the column, and it will show up for each one of these. So our change in time for each one of these was 1 second. What about for our change in position? Go ahead and click in here, and again, you have to hit equals, and we want to take the second position, which is 5 centimeters, and hit subtract, and go ahead and click where our first position was and hit Enter. And they, again, ask us, do you want to autofill this? And we're going to say, heck yeah, we want that. And our change of positions were 5, 15, 25, and so on. And notice this is the fake wheel and axle data from the worksheet, so the numbers might look familiar. How about for time midpoint? Well, to find the time midpoint, there's a couple ways you can do this, but there is an average tool that's in here. So if you go in here and choose average, we want to choose the average of what? Of the two clock readings. So if I take the clock reading of 1 and the clock reading of, clock reading 1 and put a comma and the clock reading of 2, and I'm going to go ahead and close my parentheses on there. So it's going to take the average of those two, that's 0.05, and then I'm going to go ahead and drag this down through the rest of these. Now, notice in here we've got numbers showing up in there, which we don't need. So I'm going to go ahead and get rid of those, clean that up just a little bit. And what about the average velocity? Well, to calculate average velocity, we did change in position divided by change in time. So again, I'm going to hit equals. I'm going to take my change in position. I'm going to divide that by my change in time. I'm going to hit equals, and we'll go ahead and drag that down through the rest of these as well. Again, we'll subtract out the ones that are the in-between rows. And now we've got a completed data table. From this, we could then pull out different columns and create graphs to set up each one. I hope that helped.